Very cool. All right. I think we'll go ahead and get started here. I have a little bit of introduction and then I'll pass it off to Dr. Brand. So hello, I'm Nina White. I'm a Now Core member serving as Watershed Steward and Educator here at Tinkers Creek Watershed Partners. Thank you all so much for joining. This is our second webinar in our webinar series. So if you enjoy listening to our speaker today, we have one more wonderful speaker next month. Before I begin, I just wanted to let everyone know that we will be recording the webinar and I'll be sending a link to it out to you all after our time here today, along with a short survey about your experience. So I wanted to give a quick introduction to Tinkers Creek Watershed Partners. We are a watershed-focused 501c3 nonprofit located in Northeast Ohio. Our mission is to protect and restore water quality and habitats in Tinkers Creek and Brandywine Creek watersheds through community partnerships. We engage in stream restoration projects, public outreach and education, support our member communities around stormwater and related issues, and we do webinars like these. We also host the Now Core program, where members like myself volunteer for a year of service to maintain water quality throughout Northern Ohio through stewardship, conservation, and education. If you have any questions throughout the presentation, please put them in the chat box. And at the end, I'll direct your questions to Dr. Brand. All right, I think that's it. So I'll hand it over to Dr. Brand.
Excellent. Thanks, Nina. Good afternoon, everyone. I've got a lot of slides, 34, I think, so I want to get going immediately on this impacts of plastics on ecosystems and human health. And I'm going to go in, I'm an ecologist. I have a speciality in wetlands, but because ecology is everything, biotic and abiotic, I see humans within ecology rather than the other way around, which is the anthropogenic approach, where the human species is the single most important on the planet. So let's get into this. What I consider the three greatest threats from the reading I've done, nuclear weapons, and thanks to the Ukraine war, nuclear weapons have again become more prominent. Climate change, we still are grappling with this, and it should actually, or a more appropriate might be the climate crisis, and plastic pollution. And at the end of this presentation, I intend defending the last point. I hope it's contentious, because from the reading, from what I've seen, I consider plastic pollution as an equal threat to ecosystems and therefore human health, along with nuclear and climate. So what are plastics? They're synthetic. They're manufactured from petrochemicals, from oil or natural gas. There are thousands of them. There are at least 1,000 different plastic polymers, 2 general classes with 7 main categories. And this taxonomy, because that's what it is, this taxonomy is developed by the chemists in the plastic industry. The key issue is that plastics are not natural substances. They're only about 120 years old. They're manufactured by humans. They did not exist before 1907, when Leo Baekeland produced Bakelite. And I'm sure most of us are familiar with Bakelite. It was the first very hard, rigid, durable plastic. Another plastic we're all familiar with is nylon, and that's just under, 95 years old when that was invented at DuPont Chemicals. And I say invented because this group of molecules did not exist before humans started producing them. And this is part of the problem. So here, Bakelite phones, all of us that we're used to the rotary dial, old radios, all sorts of other kitchen household items. Of course, pool, which saves elephants' tusks because the balls used to be made from ivory, bits of jewelry and buttons, and more jewelry. So we're familiar with these. And of all the plastics, these are the most stable and the most rigid and not susceptible to mechanical action. So in the 1950s, of course, plastics were regarded as the wonder product. And what is not well known, but it is well documented, is the sudden burst of plastic production in the 50s came from the Second World War, where there was an overproduction of oil, of petroleum for fuel that was needed to supply the whole war effort. So once that was no longer a necessity, there was all the surplus petroleum, surplus oil. What could be done with it? Well, let's start producing plastics. So they permeate all facets of daily life. We cannot do without them. They're lightweight, they're durable, they're flexible, they're inexpensive to produce. And that's the other key component. I remember when toys used to have metal gears and then see that change to plastic gears, nylon, which would wear out quickly. So these products now are inseparable from social and economic needs. The greenhouse gases are produced when plastics manufactured, or when rather from fracking and drilling for oils, and that produces its own carbon dioxide and methane. And I'm probably speaking to a knowledgeable audience. Methane has 4 times more the ability to absorb infrared radiation than CO2. So it's a 4 times more potent greenhouse gas. I find this interesting. 1 kilogram of polyethylene releases 6 kgs of CO2. And as I've got in the notes, polyethylene is used for single-use plastic bags and those single-use plastic water bottles. A lot of the plastic that goes into landfills are incinerated, and that produces 6 kgs of CO2. So one kg of solid material incinerated produces 6 times its amount of CO2. The mechanical reduction, so objects knocking into each other, break off bits of plastic, and as that plastic is broken off, it releases methane and ethylene. And those are both, well, the methane is a potent greenhouse gas. Some figures, they're so large that we can't really conceptualize this, but in 2019, 368 million tons of plastic were produced. In the 1950s, 1.5 tons. So in 70 years, the production of plastics has gone up by 2 orders of magnitude. In other words, 100 times. The US is one of the bigger producers of plastics, of which only 13.2% can be recycled. The rest, over 26 million tons, goes into landfills, the consequences of which we know about: leaching into water and producing methane. This is the other issue. The plastic global market was almost 700 billion in 2019. I don't have modern figures, but it's over 700 billion now. And as the second last point indicates, a 4% annual growth up to 2027. I couldn't get figures beyond that. I'm sure they're out now. But there is a continual, and it's not a straight line, it's starting to become a parabola. So the production will increase in a non-linear fashion. Everything that you can think of wants to use more plastics, all industry. So where does all the plastic go? I'm not going to speak much on these. I'm going to let you look at the image and think about that. If you're swimming, you look up and you'll see that. If you're on the surface, you'll see this. And then finally, dunes of plastics produced by tidal action. So the plastics in the ocean, we know about the gyres. We know that there are, well, that's the quantity, 8 billion tons, of which 8 million are in the oceans. A lot of this is microplastics, and it's the micro and the nanoplastics which are starting to have a greater impact. The key component of this slide is the bioaccumulation. You can see here the microorganisms, the zooplankton eat the microplastics, the smaller fish eat those, and the bigger fish eat those, ad on infinitum, and then the humans eat these fish, so it bioaccumulates. The larger pieces, of course, we know are eaten by turtles and seabirds. So each step in the food chain increases the concentration of plastics, the same way heavy metals bioaccumulate. Now, this is something on a personal level. In 2019, I was in Kumejima. Jima means island. It's the east of Okinawa. Here it is, Kume Island. It's in the middle of the Ryukyu group. There's Japan. The Ryukyu consists of about 100 islands. It was its own independent kingdom until the Japanese took it over. Here's the China Sea. There's China. Kumejima is 100 kilometers west of Okinawa. And when I visited it, this is what I found on the beach. Floating plastic bottles. There's a buoy from a fishing net. More plastic. Some of the particles are unrecognizable. More bottles, polystyrene. I'm not quite sure what those are. But this is and there's a piece of rope, which is more than likely nylon from a fishing net. The reason I'm showing you this is on the other side of the earth. And these islands are small and fairly isolated. Plastic is washing up there. These are the macroplastics, the components that float. And here we are seeing them washed up on shore. Let's come closer to home. Plastics in the Great Lake. Approximately 10,000 tons go into the Great Lakes. 2,500 tons are in Lake Erie. It's the second most polluted of the 5 Great Lakes. And because the water flows down to the oceans, you can figure out which is the most polluted of the 5 Great Lakes. It's east of us. Approximately 500,000 floating plastic objects per square kilometer. And of course, the fish and aquatic animals eat the plastic. There's a visual representation of what some angler pulled out of the guts of a fish. So these are microplastics. The nanoplastics must be in the tissue. Not must, one assumes. We haven't yet proven that. We're looking into it. So more microplastics on the beach. And finally, again, wave action with the deposition of various types of floating plastics. This is a model showing the quantity of plastics in Lake Erie. And you will find if we overlaid this with algal blooms, it's identical. Concentration in the shallow western portion of the lake, and Cleveland, not 100% sure. I think Cleveland is somewhere within this region. But if you have a look, this is the highest concentration in the lake of microplastics. And where do we get our water supply? From Lake Erie. And if we look at plastics in Cuyahoga County, 319 million grocery bags used annually. My figures are from 2019, just before COVID. They cost 10 cents. They're used for about 12 minutes. It takes 450 to 1,000 years, and you can see I've put decompose in quotation horns. Plastics don't decompose. That's part of the problem. I'll get to that now. Before 2020, we did have a limited ban on the use of plastics. Unfortunately, COVID defunct that, but we're going back to the situation now where certain stores are no longer giving plastic bags. Most plastics end in landfills. And this is the key health issue. The components of plastics leach out, they get into the water, the soil, and the air. We forgot about COVID. It seems as though it didn't even happen, but some ideas from that. This 150 billion masks are in the ocean. And these masks to animals look like jellyfish, which is a prime food for sea turtles. So that you have more masks than jellyfish in the ocean. A long lifespan in terms of living creatures. And this is sitting in the ocean, as this says, a time bomb waiting there, which will have environmental consequences of which we are yet not aware. During COVID, Hubei province produced 240 tons of medical waste daily from all the packaging used within inoculating people, face masks, gloves. Single-use plastic water bottles, plastic water bottles are the major item because they're light and they float because of the surface area to volume issue, Archimedes' principle. Most US residents have phthalates, and I'm going to come to what phthalates are in the urine and PFASs in the blood. I'm going to go into more details on the PFASs. NPR is currently having a series of programs on PFASs, interesting and disturbing. And the problem with PFASs is that they have two components of the molecules, a hydrophobic and a hydrophilic end, which mimic fatty acids, and particularly the acids that make up the nuclear membrane. So the body thinks they are fatty acids and attaches them to the cell membrane. And that's because, 80% of the cellular tissue is water. So, some other facts here. The Mariana Trench, which is the deepest point on the Earth's ocean, 11,000 meters. What's that, about 34,500 feet? There's solid pieces of plastic that have been photographed there. And we know they're in the air above the top of Mount Everest because they've been collected there. And some studies show plastics in camel tissue, and plastics live in the desert. So how on earth are the plastics getting into the camels? So this is where size matters. We've seen those examples of the macroplastics, and this is the definition science is now using. Greater than 5 millimeters, up to many, many tens of meters. The fishing nets, we saw some buoys, and they can weigh grams or kilograms. Microplastics are less than or equal to 5 millimeters. 5 millimeters, about so much. And the nanoplastics are becoming more and more of concern because they are minute. And the problem there is they produce colloidal substances, and a colloid is a solid substance suspended in water. And it's this which is the key issue. So a little more information on the sizes. That's macroplastics. We're starting to see some of the smaller components. Those are microplastics, little beads. And the blue ones, these little blue ones, come out of washing powder. And some of these are the defoliants or in toothpaste, which I know have been banned. The point is, they're still in the environment. They haven't gone away. They will be there basically forever and a day. These are the nanoplastics, and you see these white wedges down here? Those are the nanoplastics, and you cannot see them with an ordinary a 10 or 50 power optical microscope. You need very powerful microscopes to see these. So all plastics float. The specific gravity of most plastics is slightly less or equal to that of water. So why is this problematic? This is a list. I'm not going to go into the names of all these different plastics and their density. This graph gives the density there below and the type of plastic above. And you can see bottle caps, because they're hollow, they act like a boat. So their volume to surface area is such that the amount of fluid they displace allows them to float, also because they're plastics. So some will have slightly greater densities. They will sink, but they still remain buoyant. And that's the problem. The reason that the plastic is sitting at the bottom of the Mariana Trench, I'm going to get into shortly. So pardon me, let me use that, then it's a little easier to see. So these are some of the issues around the pollutants here. Plastics, unlike natural substances, do not oxidize. Metals will oxidize. So metals can be broken down into their constituent components. Most rocks have metals in them, so it's a geological constituent of planet Earth. All metals can be weathered. Rocks are weathered and will break down into their mineral components. Any wood gets broken down by fungi and bacteria. So everything other than plastics has been on the planet and is a component of the planet's biochemical and oceanic cycles. Everything is broken down on the decomposer level in ecology and is recycled. Plastics do not break down into non-plastic components. All they do is the amount of material breaks down, but it still remains as the original plastic polymer molecule. So there's a size reduction, but the chemical composition remains unaltered. And that's the issue. And as each plastic breaks down, as they break, they release greenhouse gases, particularly methane. So there are two classes of plastics, thermoplastics and thermosets. And I've deliberately changed the color. Thermoplastics are these little pellets. Those can be remelted and can be recycled. Some are polyethylene, polypropylene, polyvinyl chloride. The thermosets are heat informed, so they're injected into a mold by heat and pressure. Tires on every vehicle we see are thermosets. They cannot be recycled. Also because, as you know, with tires, there's metal in there and there are other components, there are other chemicals in there, sulfur included, to make them harder, longer lasting, less, and make them puncture resistant. Here are the 7 main categories. Again, this is what industry has used to define the 7 main categories of plastics. I'm not going to go into this now. The slide will be available. If you want to, you can look at it. But the colors denote the first 2, 1 and 2, can be recycled. 3 and 4, polyvinyl chloride, and the low density polyethylene. So it's the bags at grocery stores, cannot be recycled. Types 5, 6, and 7, some of these components can be recycled, some cannot. And class 7, I'm going to go into a little more detail because this contains BPA and it contains the other plastic softener phthalates. So here's this whole myth that the plastic industry created, which made us, the end users, responsible for recycling, and the myth they created that plastics can be recycled. So as I said earlier, the thermoplastics, category 1 and 2, can be recycled. The thermosets in red, 4, 3, and 4, cannot be recycled. 5, 6, and 7, some can be recycled. And let me go into this. Okay, so here's the BPAs. It really means bisphenol A. We have enough data to show that they cause endocrine disruption. And this is possibly the cause from the mid-late 60s onwards for the sudden appearance in males of testicular cancer and issues around endocrine disruption in women, pregnant women, and some of the issues they have with newborn babies. There's not a direct link yet with a lot of this research. It has not been done. The phthalates are the plastic softeners, and these are found with something like cling wrap and no plastic. So these are released and absorbed by the fatty acids. So when you go to the grocery store and you buy meat in that plastic container and it's covered with cling wrap, the cling wrap is made soft by the phthalates, and that's absorbed into the meat, and we eat the meat or the cheese or whatever is wrapped in it. They cannot be recycled. So let's have a quick look. What's in your house? I took these photos, and you can see these are blueberries, and it even says blueberries. And you can see here, here's the little diagram with the number 1, and it gives the type of plastic. This is the underneath. There's the number, little diagram. That's the bottom of the liquid, dishwashing liquid used in tumbled in spin dryers, in washing machines. This is a contact lens solution bottle I bought in Okinawa. And you can see it's got a number 4 underneath it. And I put that in because it shows wherever plastics are produced in the world, they use this categorization, this taxonomy. This is the bottom of a yogurt container. And that's, I think, a 5. That's polystyrene with the sign, the recycling symbol. And here's cling wrap, and you can see it actually has written microwavable safe. No plastic is microwavable safe. They're all derived from oil, and all oil has volatile components. If you heat plastics, it will release the components. And I put this on to protect cling wrap in case there was an issue. I'm pretty sure everyone can read cling wrap in there. In any event, to reiterate, no plastic is microwavable safe. And I was horrified to see on baby formula bottles saying this plastic is microwavable safe. So women are putting the milk in the bottles, heating it up, and feeding their baby phthalates and other plastic components. So health impacts, 2 main types, the chemicals and the solid plastics. I've gone into some of the toxic components, but the issue here is that these are novel. They have never before been on the planet. They're exclusively the product of humans. Consequently, the systems on the planet have not evolved to be able to deal with plastics and literally break them down and reduce their molecular composition. And this is a reiteration of no plastic is safe to heat. My other concern with plastics in containers, we all go to takeouts, we get hot takeouts. What do they put it in? They put it in a plastic container. Immediately that plastic container gets soft. It's leaching volatile plastic components, phthalates and maybe PFASs into the food, which we then take home and eat. And none of this has yet been quantified sufficiently to provide evidence to link these to the health and the ecosystem problems. And of course, we know solid plastics, the physical issue of entanglement, ingestion, or inhalation. Here are the 4 main categories of health impacts. Carcinogenic, causes cancer. Mutagenic, changes the structure of the DNA, which then produces a mutated fetus. disrupts the endocrine system, and those are the various internal male, female producers of sex hormones, the thyroid, the adrenaline glands, noradrenaline glands, all of these internal glands, which are extremely important for moderating human behavior, digestion, reproduction. And this last one, I was interested to see plastics are now having an effect on antibiotic resistance. They're making bacteria more resistant to the various drugs we use to reduce infection. I'm going to go into that shortly. Let me deal with the first set of health impacts. So inhalation by municipal wastes burning, which are releasing these polychlorinated biphenyls. We're hearing about these in the news. We know about dioxins, Agent Orange, furans and mercury. And mercury, of course, is a heavy metal, which is a component of the geology of the planet. We know mercury comes down out of the rain from volcanoes. So mercury is everywhere. Polyvinyl chloride, freeze halogen. Sorry, there's a lot going on internally. And of course, this also is adding to climate change with the production of these greenhouse gases. We now find all fresh water has plastics in them. And the beer industry in Germany, they understand that water quality is the single key factor in beer production. They have peer-reviewed publications of 12 beers tested for quality. Of those 12 beers tested, 8 of them had plastics in the beer. And of course, bottled water, the softer the bottle, the more phthalates, the more plastic softeners, the more is leached into the water, which you then go and drink. I no longer use anything which is plastic. I use glass or metal. I don't know how much that's helping, but one must do a little bit. We are unsure of the total impact on pollinators and other animals. We do know about some of this, and plastics have been found in honey. And this is now documented that it's actually coming from the pollen, which means the plant is absorbing the plastic through the water, depositing it in the pollen. The bee takes the pollen to the hive and makes honey, and we eat the honey. This is the thing with ecology. People say, well, you're a rocket scientist. And they go, oh, yeah. Well, comment, ecology is even more complicated than rocket science because of the impacts. So a couple of these issues around carcinogenic, mutagenic, and endocrine disruption. We now know that it's in the crops. It enters the food through the water. And then it enters the food chain, which is a component of ecosystems and ecosystem health. And as in Cuyahoga, we are reliant on the ecosystem functions and ecosystem services. We drink the water. The water is used in cleaning, in growing crops. So we're recirculating these plastics. We're aware of dioxins, which are produced, that chemical number 6, some of which can be recycled, some can't. Dioxins are the plastics that use dioxins cannot be recycled. We know about polystyrene. It's a fantastic insulating product. But some of these, the side effects are that it disrupts the nervous system because of these brominated compounds. And the brominated carcinogenic and mutagenic effects are documented. Here's the antibiotic resistance. So what happens here is, because the plastics are quite small, They leave the washing machine, they go down the washing machine, and they go to the sewage plant to be reprocessed. And there, because of their size, bacteria attach to them, and it forms this bacteria-rich microplastic sludge. And the more bacteria you get combining around a plastic, the more and more mass they add, so the lower and lower the plastic sinks in the water until it actually has enough bacteria around it to make it sink and get covered with more sludge. The genes that the bacteria then produce in their evolution promote antibacterial resistance. So we drink the water and start producing a resistance to our antibacterial drugs. There are a few papers on this, which are extremely interesting and potentially disturbing. Here's some details on the PFASs. This end is the hydrophilic. So if the cell perceives this, it regards it as a fatty acid. This is the hydrophilic, the water-loving. That's the hydrophobic. And if any of you know anything about the structure of the membrane that surrounds the nucleus, you get a water repellent side on the outside of the cell membrane because the membrane doesn't want water entering it. It will expand and dilute. It wants the hydrophilic, the water-loving, on the inside. So these PFAS chemicals then attach to the cell membrane, and these we know are toxic. The research has shown that approximately 98% of people in the US have PFAS in the blood. The exact health implications are not yet manifest, and they are not yet well researched. The EPA guidelines are 4 parts per trillion, but research is starting to show that at a minimum it should be 2 parts per million, but ideally 0. So some of the health impacts if animals actually swallow plastics. They reduce fitness and they cause death. And the fitness here is inferred as Darwinian fitness, so the fitness to be able to breed and to pass on your genes. It's reducing that ability. It amasses in the ecosystems with all the negative effects contingent on that.
Just to let you know, Dr. Brand, we've got about 10 minutes left with the presentation.
Thanks, I'm getting towards the end.
Awesome.
The impacts of nanoplastics are largely unknown. And this I find disturbingly interesting. About 100 metric tons of plastic are deposited by rain in the deserts in the western part of the US. So if you're out in Colorado or further south in New Mexico and you come across a little stream flowing out of the mountains, let's say Red Rock Canyons, and you go, oh, lovely, fresh, clear water, let me drink some of this. Well, it's going to have plastics in it. And again, these effects are all exacerbated by climate change with increased temperature to leach out more components from these plastics. So some not so trivial plastic questions. Which country is the cleanest and has the least plastic? If any of you want to quickly put something in there or raise a hand, any ideas? 3, 2, 1, ping, Rwanda. Any ideas why? I have a friend who went to Rwanda. This is some years ago. And they said they opened their suitcase at the airport and the inspector looked in there and saw they had those blue plastic bags wrapped around shoes and items. My friend thought they were going to A, be arrested and B, kicked out of the country immediately because all plastics and plastic bags have been banned since 2007. Now, if Rwanda can do this, why can't we? We know why, though. That's a rhetorical question. There's a website you can find more on that. So to conclude, we know plastics are here to stay. They're throughout the planet. We now know they're in the air, the water. the soil and in us, but there's a huge industry involved in it. There's a vast amount of money. What you can do, so every little does count, reduce use of plastics, know the 7 types of plastics, recycle what few can be reused, and this will reduce the amount of plastics going into ecosystems and their effects. So have you been convinced? Any curses, any comments? Thank you.
Thank you so much, Dr. Brand. That was amazing. I learned a lot. I will be looking back at the webinar recording and taking many more notes.
Good, thank you.
Yeah, awesome. I'm looking for questions. If anyone has any questions, please go ahead and throw them in the chat.
It looks like Judy has her hand raised, Nina.
Oh, Judy, go ahead.
Hi. Hi, Robert. Thanks for this information. It's wonderful to know, and it's also highly distressing. So what I'm wondering is this: can those micro and nanoplastics be somehow filtered out of water? And that's asked with the understanding, like, we're talking about the ocean, the lakes, the rivers. It's way too big of an undertaking. But what about, say, like RO filters in your home? And also then related to that, is anyone doing research on how to filter those plastics out? Of course, then I don't know what we would do with them. Maybe shoot them into space. Thank you so much.
No, we can't put our problems out to space, well, unless they fall into the sun. So let me answer the first part of your question about removed from the water system. So the water treatment plants in Cuyahoga County have this as a concern because of the size of the nanoparticles. And nano is 10 to the minus 9, so it's a billion. They're so small that even if you have if you have a reverse osmosis process, because they're so small, if water can pass through permeable membranes, so will the plastics. The point there being, as with most filtration systems, there's a reduction in size of particle through each step in the filtration process. So some filtration would be better than none. I have spoken to the sewer district about this. It would be extremely expensive. They would need to set up specific settling reduction tanks after the biosolids. All the solid waste now is called biosolids because it's not just human feces. There's a lot else that goes into it. I don't know how many people put items down their drain and then flip the switch and it liquidizes everything. So there's a lot of additional organic material that goes into the treatment plant. They certainly can remove the macroplastics. And the single biggest problem, or the single biggest item, are the ends of cigars and cigarettes, those filters, the little holders. That's the single biggest item. It used to be the tampon inserters, but that's now gone off the market. I remember seeing the lakeshore, Lake Erie, after one storm, and I wondered what all these strange, long, white plastic containers were. They were tampon inserters, but that's been taken off the market. So yes, some of this can be removed, and that doesn't mean to say attempts should not be made to do something to remove some of them. Some are very difficult. The nanos are very difficult. I am in the process of collaborating with Tinkers Creek and the Cuyahoga Valley National Park to start researching methods of A, removal of solid plastic, and B, then looking at chemical composition, so type of plastic and amount of plastics. There is someone who paddles his canoe up and down the Cuyahoga River at the mouth and actually removes solid plastic by hand. He's doing this on his own at the moment. He would be an extremely useful and interesting person to associate with and to be able to expand what he's doing. Because every bottle he takes out is one less that's going into the oceans. So, yes, and I understand that a lot of what I've given is distress causing to an extent. That's part of my aim, but my aim is to use that to try and enlighten people to start thinking and to start doing. If you're not informed, you can't do anything. If you're informed, you can then decide what you can do. That's why I've put this up, what you can do. And it might seem like very little, but how else can we act but on an individual level? So that's some of what you can do. I hope I've answered that question. Not fully, but partially.
Yes, thank you. That was awesome.
Thank you. We've got some more questions that came in. One of them being, can you touch more on the damages of incineration and chemical recycling as this is being touted as the new silver bullet?
Okay, so while I try and... Okay, what did I see? Burning. All right. And again, as I had the slide further up, that it's a plastic industry that's put the onus on us end users to be responsible for recycling. You know, ultimately, we are not responsible for extraction of petroleum, production of plastics, and the dissemination, the use in products. The industry, the extraction industry, and the production industry should be made responsible for how their products end up being used. It shouldn't be on us, but currently it is. Burning plastics releases a suite of toxic chemicals. Dioxins are one. It also releases soot particles, so it releases solid particles. And that goes to the issue of solid particulate matter, which exhausts from internal combustion engines release. And the problem with particles of 2.5 microns or smaller is that when they're inhaled, they get trapped in the alveoli. And they are so small that they get trapped at the bottom of the alveoli and the body can't get rid of them. So even with the production of mucus in the lungs, because that's what happens when we cough up phlegm, it's the mucus is being trapped in there, the solid particles are being trapped in the mucus and then expectorated. So that doesn't happen with these small soot particles, which is a component of combustion. There are scrubbers at reputable plants, but sometimes, and I can't speak for the US, I do know about South Africa, when a rainstorm comes in, the scrubbers are opened and everything goes into the air. So the solid particulate matter, as well as the actual chemicals, are the issues around the inhalation of plastics after burning. And of course, everything you release into the air is going to eventually go up and come down again in rain or just as dust. So that's how it gets into the water, into the soils, into the whole food chain. And what was the other component? So burning, and I think I've answered that, have I? Okay. Any other questions?
Yes, we've got a few more. The next one was, I've heard about studies where they're trying to see if bacteria will consume plastics with the hope that they can digest them and break them down to help us deal with the problem we've created. Do you have any knowledge of this?
There is some work, and so there's A, research, and B, direct observations in ecosystems, that there are a few species of bacteria which seem to be able to digest plastic. This is very early days. Two problems around this. There's always this belief, and I use belief correctly here, because belief generally is applied to religion, but it's applied to the suspension of personal belief that there's something outside of us which is bigger, something metaphysical, which will take care of the problem. So the belief is that the bacteria eventually will evolve methods to deal with the digestion of plastics. Let us assume, in terms of ecosystem functions and bacteria, that this might happen at some future time. The point being, evolution can either be punctuated, so very brief periods of time, the KT boundary meteor impact, where that occurred in 100,000th of a second. The results then spanned a long time. So that's pulsated evolution. The other component of Darwinian understanding of evolution is that it takes a long time. How long? We have no idea, because these are novel chemicals that the planet, the organisms in the planet, have never before had contact with. So they don't know how to recognize it or what to do with it. So trying to rely to say, oh, well, at some future date, the bacteria will eventually take care of this. A, we have no idea what the time span is. And B, this is now a moral issue, because we are well aware of what our actions are doing to ecosystems. So we do have, I believe, a moral imperative. This is environmental ethics. We know about the consequences. So yes, there is some evidence and there is some research that a few of the 150,000, I can't remember how many bacteria species off the top of my head. And it certainly is possible that bacteria, and there is some interesting research being done on fungi, because fungi, they're white generally, they don't use photosynthesis, so they have to produce really potent enzymes to break down the material to be able to produce sugars, to be able to then produce their metabolic processes. So there appear to be some bacteria that can actually break the plastics down back into petroleum. But these are very early days. And that's why I put those figures up in the earlier slides, to show how many hundreds of millions, thousands, and billions of tons of plastic are currently around, literally around the planet. And that for either fungi or bacteria or both organisms to start dealing with this, there's a huge volume of the materials. They spread everywhere. We do not know how much time we have and how long this will take for fungi and bacteria to actually start having a positive effect by breaking down the plastics. And I can go on, but I'm not going to. There are other questions.
Awesome, thank you. The next question actually was a tag along to that about the fungi breaking down plastics. So thank you for touching on that. And if there's any follow-up questions to that, feel free to throw them in the chat. But the next question we had then, someone's organization stops macroplastics from entering larger bodies of water, but they have no ability to stop the micro or nano from flowing downstream. In terms of triaging the crisis, is going after the macroplastics problem a good start?
Removing any plastics is a good start. So my answer to that is an emphatic yes. It's an unequivocal yes. Remove what solid plastics, what macroplastics you can. I'm in the process of setting up various projects to start looking at plastics. So anyone who's listening, my email is there. Email me and let's see how we can start collaborating on this. It needs a combined effort. I would like to see the Watershed groups, a lot of industry, individuals, whoever, collaborating on starting to at least remove macroplastics, because they break down into micro and eventually nanoplastics. So it's easier to move a big thing you can see than trying to remove nanoplastics from the water column.
Awesome. Thank you so much. I think those were all the questions that I saw. But if anyone else has a question, pop it in the chat, really quick, I know we're approaching our end time, and I want to be respectful of everyone's time. So um, I want to give a big thank you to Dr. Brand and to all of you for attending the webinar today. I'll be sending up a follow-up email with information about the recording link, and a short survey that I would super appreciate if you'd fill out. It helps me a lot with my data I have to report for NowCore as a whole. So yes, for anyone who has to leave, thank you so much. And we did have one more question that came in. What do you think about pyrolysis through microwaves? I hope I pronounced that correctly.
Say that again.
What do you think about pyrolysis through microwaves? Pyrolysis.
Burning through microwaving is the question. Is that the question? Pyrolysis through microwaving?
Through microwaves.
Oh, through microwaves. If I understand the question, put plastics in a microwave or put them in some large container where you can zap them with microwaves. I haven't heard. Oh, well, that would be heating plastics in an oven in a microwave. Or is the question more getting rid of plastics by microwaving them and turning them basically into a gaseous microplastic? I'm not quite sure. But if it means the former, heating something in plastics in a microwave, it will release the leachates, which then get into the food or the liquid, which we're going to ingest. No plastic is safe to microwave. Glass, an inert substance. Obviously, we know we can't put metal in a microwave. So put it in something ceramic and put a ceramic top. Do not put plastic. Or put a cardboard or a paper top on that, or 2 plates. But all plastics, because they come from oil or natural gas, are volatile. And if you put microwave energy into them, it will liberate some of the plastics, whatever they are, including the more toxic components.
We got some clarification on the question. Using microwaves to turn them back into fuel and natural gas, shooting microwaves at the plastic, not the kitchen appliance.
Oh, okay. I have not heard of that approach being used, so I can't comment on that. And that's interesting. It would obviously require a lot of energy. And I don't know if it would work on all the 1,000-odd different types of plastics. If whoever asked the question can give a reference, I would be interested in it, but I've not heard of it before.
Awesome, thank you. I'll go ahead and re-put your email in the chat. So anyone who wants to follow up on anything with Dr. Brand, please feel free. Yeah, and awesome.
Yeah.
Yeah, thank you so much, everybody. If there's no other questions, we'll go ahead and wrap up for today.
All right. Thanks, everyone, for listening. And thanks, Tinkers Creek, for giving me the chance to present. And maybe people came in late. This will be made available online, correct?
Yes, I will provide a link to the webinar in my follow-up email to everybody.
And I will need to send you a copy of this, otherwise no one will be able to get it.
Yes, please.
And I'll have to figure that out because I think it's too big to go via email. But that's between us afterwards. Thanks very much.
Thank you. Have a great day, everybody.
Thanks. Bye.
Thank
Bye.
you so much. Bye.